All right, so this problem says okay, so what we'll do is we'll do part H. What we want to do is we want to find this. We want to find A minus 4D plus 2F. Okay. What is the result going to be? This is a vector. What is this? A vector plus a vector. So the sum of three vectors will be a vector. Okay, so we want to find that. Now, when you do algebra, what is it that you want? You want to see here's the vector A. What you want is the vector in component form. That's when you do algebra best. Okay. And now, before I do this, all right. So if you have a vector A, how's the x component given? It's given by A cosine theta, where theta is an angle measured counterclockwise from the x-axis. Okay. Now, for this vector, for instance, if you wanted to use that formula, you would have to use this angle, which would be 300 degrees. Okay. Yep.
Would you not get the same value by just using negative 60 degrees?
Yeah, you could do negative 60 degrees. Sure, you could put cosine negative 60 degrees. Okay. But I want you to. All right, here's a useful thing to learn. Okay. So what we'll do is we'll do an acute angle. If this is the hypotenuse, the opposite side is A sine theta, and the adjacent side is A cosine theta. Everybody understand that? Okay. So here's the hypotenuse. For this triangle, this is the adjacent side. That would be C cosine 60. And this side would be C sine 60. Okay. Now these. Oh, it froze. I don't know what's happening. I had the hardest time connecting. I had to reboot my computer and so on. So I don't know what's going on. Anyway. All right. So what you want to do is you want to figure out the adjacent side and the opposite side, and then put in the signs by hand. Okay, so this is the y component of C. That would be negative C sine 60. This is the x component of C. That would be plus C sine cosine 60. Okay, so hopefully the recording didn't drop. Okay, so everybody understand we'll be using this. The opposite side is hypotenuse times sine theta. The adjacent side is hypotenuse times cosine theta. Okay? So that's how we're going to find the sides. Okay. All right, so we're doing problem H, which is we want to find A minus 4D plus 2F. Okay. A is, there's the vector A. Its length is 10 units. This is in the first quadrant, so there's the x component, and there is the y component. Okay. So A is 10 cosine 30i plus 10 sine 30j. Okay. So there is A. Okay, so again, we are writing the vectors in component forms because that's when you can do algebra easily. All right, let's do D. There's D. Okay, so this is the opposite side. This is the adjacent side. D is, okay, 20 cosine 37. So that gives you the length of the adjacent side, except that this is pointing in the negative x direction. And so you have to put in the sign by hand. I plus 20 sine 37 j. That was positive. Did you guys understand that? Okay. Had you measured the angle from the x-axis like this, had you done that as 143 degrees, that would take care of the sine by itself. So 20 cosine 143 degrees I plus 20 sine 143j. Okay, this would equal that, and this would equal that. But it's one step extra to find the angle this way. So getting used to this method is easier. Okay. So you can do it any way you want, but that's, yes. Did you still have your question? Okay. So D is 16I Okay, and the third vector is F. There is F. Okay. So I'll redraw F here. F is 20 units and 30 degrees. Okay, I have trouble with F. Who can help me with F? Okay, so there's the adjacent side. So minus 20 cosine 30I. And there's the opposite side. Minus 20 sine 30j. All right, now that we have component forms, now we can do all kinds of algebra. Okay? So what is it that we want to find? We want to find A minus 4D plus 2F. Yeah. So therefore, A minus 4D plus 3F is equal to, what is A? A is 8.66I. Minus 4 times D is 1612. So now you combine all the I terms, you add up the I vectors, okay? So it's 8.66 plus 64 minus, okay, so, and let's give this a name, the resultant vector. So the resultant vector is, the x component is 8.66 plus 64. The plus 64 came from there. And then minus 51 point. So that's the I component. That's the x component. Plus the y component would be 5j 5 plus minus 48 and then minus 30. So this is equal to, that's 52, 12.1, 20.76. And this is 25, 53, 73. Okay, so there's the resultant vector R. Okay. Yep.
Can you explain the step with the trigonometry better with the angles and the vectors?
Okay, so the idea is the following. You have to remember this, if this is the hypotenuse, this side, sine theta is opposite by hypotenuse. So the opposite side is h sine theta. Cosine theta is adjacent by hypotenuse. Okay. So that's what you want to remember. So again, theta, hypotenuse, h cosine theta, h sine theta.
How do you determine when you make the hypotenuse negative or positive? I saw that you did it in the algebra steps.
Oh, no. So, no, all these guys are positive. This is positive, this is positive, this is positive for an acute angle. Now we'll apply that to a vector. So let's say your vector is pointing like that. This is your x-axis. So this is 20 units long, the hypotenuse. This is 30 degrees. So this length is 20 cosine 30, and this length is 20 sine 30. Let's say this is vector A. The x component is this length except that it's negative. So it's negative 20 cosine 30. And the y component is this length except that this is pointing in the negative direction. So you put in the sign by hand based on where the vector was. Yeah. If you didn't want to do all of that, what you could have done is you could have used this angle, which was 210 degrees, but that's not a stepped calculation. Or you could, as our friend here pointed out, you could have done this, which was minus 150 degrees. All those would give you the same answer. So this would be 20 cosine 210 I plus 20 sine 210j equal to 20 cosine minus 150I plus 20 sine minus 150j. They all would give you the same answer. But when you do a lot of these problems, this is the best way to do it. Okay? All right, any other questions? Yep.
When you were copying down the answer, I thought it was supposed to be plus 2f, not plus 3f. On the.
Okay, so
when
it's,
copying down the next step, you put plus 3f.
all right. So that step was to test how many people were awake. Yeah. So we just changed the problem. Yeah. Any other questions? All right. This is a similar problem. I'll just read one step. It's a bunch of vectors, adding vectors, and I don't want to, it's 6 or 7 vectors. So, all right. So what you want to do is in these things, is the following. So here's your x-axis. Again, that's standard practice. Your x-axis is horizontal. Your y-axis is that. Okay. In an attempt to escape a desert island, a castaway builds a raft and sets out to sea. The wind shifts a great deal during the day, and he is blown along the following directions. So the first leg of the journey is 2.5 kilometers, 45 degrees north of west. So the first vector would be, okay, the first vector would be, this is 45 degrees north of west, and the length of this vector is 2.5 kilometers. Yeah. Then the next leg, which would be from here, but we're going to draw all the vectors from the origin. Okay. So his next journey would be from here. And we're just going to draw it here because, when you add the vectors, you just shift it there. Okay. So his next journey is then 4.7 kilometers, 60 degrees south of east. So vector 2 is that 60 degrees south of east, and that's 4.7 kilometers. Yeah. And then so on, you draw all the vectors, and the resultant vector will be just will be the sum of all those vectors. Okay. So I don't want to spend the time doing all that. I mean, that's several vectors, 2, 3. So, but that's all you do. Okay. Just add up all the vectors. Did you guys understand that? Okay. Okay, we'll do one more of these. So here's A. So now we're dealing with 3-dimensional vectors. Okay. So here's a vector. This is a position vector. See, from the units, you can tell what kind of vector it is. So if the unit were meters per second, what kind of vector would that be? Yeah. If the units were newtons, that would force. If it was meters per second square, then it was an acceleration vector. Okay. So from the units or dimensions, you can tell what kind of vector it is. Okay. The ijk. So let me illustrate this. So this is a. Okay, so here, what did I write here? See, now this is a velocity vector. Okay, the units are attached to the components. These I, J, K are dimensionless. Okay, see, we use the same I, J, K for all different vectors. Okay. Did you guys understand that? Okay, so the units are attached to the components. All right, so here's vector A, here's vector B. Let's find this fella, okay, B. So vector D is 2A minus B. And again, can I add apple to an orange? No. What does that mean? If this is a position vector, that has to be a position vector. I can't have this being position vector and that being a velocity vector. Okay, so that would be adding different objects. Okay, so 3i minus 4j Okay, so if somebody tells you vector A is equal to vector B, how many equations is that? I'm sorry? One. Everybody agree? Okay, so this is, if when somebody writes like this, that's 3 equations. See, when you write like that, what that means is this component is equal to that component, that is equal to that, and that is equal to that. Okay, so that's really 3 equations. If these vectors are n-dimensional vectors, then it's really n equations. Okay, so you see this is a nice shorthand way of writing 3 equations. Okay, so you have to keep that in mind. Okay. All right, so we'll solve this problem. Let's look at these vectors. See, each of these vectors is, this is 2-dimensional, B is 2-dimensional. They're all 2-dimensional vectors. Okay. So when you write this, what is this guy? What's that? Huh? Yeah, 0 vector. How many numbers does you need to specify that 0 vector? 2. The x component is 0 and the y component is 0. This 0 vector is not the same as the number 0. It's 0i, 0j. Okay? Had we been dealing with 3-dimensional null vector, you would have to, this would be 0i plus 0j plus 0k. Okay? This guy, of course, is different from this guy. Okay? All right, so the point of all of that was they want you to find want you to find these 2 constants. Well, you have 2 unknowns and you need 2 equations. Now, before we started, this would have looked like it was 1 equation, but now we know it's 2 equations. Really, the x component of this vector should equal the x component of that vector. The y component of this vector should equal the y component of that vector. So you really do have 2 equations. So a dx plus b bx plus ax equal to 0. A dy plus b by plus ay. Okay, so that's what we wrote. Did you guys understand that? Okay, so now you have 2 equations and you can solve these things. Okay, now let's substitute the components. So this is 6a and bx is minus 8, minus 8b, ax is 26. And I will bring the 26 on the other side, so minus 26. So this you get from the x component. And from the y component, so a dy, dy is minus 8. So minus 8a, and bby, there's 3b, and ay is 19. So okay. So now you have two equations and two unknowns, and you can solve for those. Okay. Everybody understand the setup? Do you want me to solve it, or you guys got it? All right, I did two steps. AY was 19, and then I brought it on that side and become minus 19. All right, are we good with that? Should I go on to the next problem? Anybody want me to solve this? Okay. So this says find the angle between vectors. Okay, so we'll do this one. So here are three-dimensional vectors, and we want to find the angle between the vectors. Okay. These are both position vectors. Okay. So what they're asking you to do is find the following. So let's say this is D, this is B. They're asking you to find this angle between the two. Okay, so you're drawing those vectors from the same point, and they want you to find the angle between the two. Okay, whenever you want to find some variable, you need an equation that involves that quantity. And if you look at your notes, the dot product of two vectors involves those two quantities. So the dot product is defined as the magnitude of D times the magnitude of B times the cosine of the angle between the two. So here's an equation that involves the angle between the two. Okay? Well, if you want to find this, you need to know everything else. The length of the vector you know from the components. You can find the length. The length you can find from the components. How do I find this? I seem to know this. Well, but I can write this dot product in terms of components as well. Okay? So that can be written in terms of components. dx bx plus dy by plus dz bz. Okay? So cosine theta is dx bx What is the formula for the magnitude of the vector? Anybody remember? Yep, very good. Okay, so cosine theta is dx bx. Dx bx is minus 4 minus 12. That's minus 16 plus 2 minus 14. If you did all the math right, what should this be? This number should be between minus 1 and plus 1. Okay, so it should. Okay, so you can see that it's less than 1. So 137.8 degrees. Okay, so whenever you want to find the angle between two vectors, what you do is you use the dot product. Okay? So the dot product involves the angle between the two vectors. Okay, now we'll do the other product. We'll do the cross product of two vectors. Okay. So let's choose a three-dimensional vector. So here is A, a three-dimensional vector, and C, another three-dimensional vector. Okay, so A is 3i plus 4j plus 10k. C is 2i minus 4j plus k. Okay, and what you want is A cross C. Okay, we'll call it the resultant vector. And you guys remember A cross C, we defined if A is a vector like this and C is a vector like that, A cross C is a vector perpendicular to that plane. How do we determine it? If you turn from A to B, A to C, if you turn a screw like that, the screw would move in that direction. Okay? So that's, and you're using your right hand. The right hand rule shows you the direction of the cross product. The first vector crossed into the second vector gives you the direction of the third of the cross product. Okay? All right. So again, you can so I j k. Okay. So the ith component, the x component is ay cz, ay cz minus the opposite az cy plus the y component is az cy, az cy minus the opposite, oh, cx. Minus ax cz. Notice the y component doesn't contain the y components of the vectors. The x component doesn't contain the x component of the component vectors. Okay? Plus the z component. Who wants to help me out with the z component?
AXCY
Very good. Ax cy.
minus AYCX.
Mm-hmm. Okay? So there's the cross product. And now we can fill in numbers. All right, I'm going to use the space over here. Okay. So R is equal to AYCZ, AYCZ. Okay. So this is the minor AYCZ minus that. Okay, so 4 minus of minus 40, which is 44, 44i, and then this guy, AZCX minus this guy. Okay, so that's 20 minus 3, 17j. And so if you do determinants, you'll recognize them as minors. Okay, so the kth component is AXCY minus 12 minus 8. So minus 20. Okay. Okay, so there's the cross product. And so the cross product is a vector. Okay, and that vector is perpendicular. This vector is perpendicular to the plane defined by these two vectors. Okay, perpendicular to the plane containing A and C. Yep. Mm-hmm.
Would that be similar to saying that vector R is perpendicular to both vector A and vector C?
Yeah, so if this is A and this is C, this defines a plane, and the cross product is perpendicular to them. So it will be perpendicular to every vector in this plane. Yeah. Okay, this is a dot product problem as well. I'll let you guys figure that out. This is a little more involved, so let me do this one. Yep.
Like matrices to do this?
Yeah, yes. So now determinants, you can do determinants. A, R, this here is that. Yeah. Okay. How many dimensions, how many components does this vector have? Is that a vector in, that is a vector in how many dimensions? 3 dimensions. How many numbers do you need to specify that vector? 3. Okay, so generally, so G, it could be Gx, Gy, Gz, or it could be G theta phi. So this is the components of the vectors, x, y, and z component, and this is the magnitude of the vector, and these are the two angles. There's the angle theta, and that's the angle phi. Is there any other way to specify this vector?
So you could do any combination of those.
You could use any 3 numbers. You could use this, these 2, you could use these 3, 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 so any 3 numbers. Okay, to specify that vector. All right. So this notation is, this should be really, that should be gy. So maybe you can fix that. See, that gy is 10, okay? And since this is 45 degrees, what is that equal to? For a 45-degree right triangle, the 2 sides are equal, so that's equal to gx as well, okay? So we have gx equal to gy equal to 10, and that's, okay, so this is for, yeah, part A. And then what we don't know is, we don't know the length g, okay, so we'll find that. All right, so let's see, so this is a right angle triangle, okay, there's the 90 degrees. What is this side equal to? Let's say this is g, this is equal to g sine 60, which is equal to that. And then gy, so this is equal to g sine 60, and gy equal to g sine 60 is the hypotenuse, and that's 45 degrees, so sine 45. So g okay, so G works out to 16.3 units. All right, so the problem asks you, find the scalar components of the 3 vectors G and Y. Okay, so now that we have the magnitude G, now we can calculate GZ. GZ is G cosine 60. Everybody see that? This is the adjacent side, and so that's G. Okay. Okay, so the vector G is 10I plus 10J plus 8.15. Okay. So you can do the same thing for this guy. All right. So here's the x component, the y component. Okay, so you can see that for this vector, the x component is negative, and the y component is positive, and the z component is positive. So for this vector, x component is negative, y component is positive, and z. Do you want me to do this problem? All right. So what are the three numbers given? So remember, you need three numbers to specify a three-dimensional vector. HY is given. This is HY. Okay. So there's a few typos in this problem. HY is given, and these two angles are given. So you have three numbers. Okay. Okay. So this number is given, and these two angles are given. Okay. So what we'll do is we'll find again. We'll find H first. Okay. So H sine 45. This is H sine 45. And this is equal to that, and this is 30 degrees, and so that times cosine 30 is this guy. All right, so HY is H sine 45, H sine 45 times cosine 30. And HY is 15. So the magnitude of this vector H is 24.5 units. Okay, and then from here you can calculate Hz. This is H cosine 45 is Hz. Okay, Hz All right, so we have HY and we have HZ, and now we need to calculate HX. And that is equal to this fella, which is H sine 45 times sine 30. Yeah. And we're putting in the sign by hand. HS is negative, H sine 45 times sine 30. So that vector H is minus 8.66I, and Y component, what was the Y component? 15. All right. So again, what was the problem? What this problem illustrated was, to specify a three-dimensional vector, all you need is three numbers. It could be any three numbers. It could, I mean, generally the polite way to do it, to express them, is give these components or these guys. And so in this problem, what you got was these three numbers, and from these three numbers, you figured out those three numbers. That was the problem. Okay? All right, guys, so let's take a quick